Here are the first day of notes for section 3.2, graphs of functions. Now, I've gone through with you the idea of creating a table for these functions, and what we want to do is continue to use a table of values to graph the functions using the strategy of setting the part of the equation that is affected by the function equal to 0, with the exception of the square root or other even root functions. We want to set them to be greater than or equal to 0. So, for example, if we had absolute value of x plus 3 and then minus 8, we could identify the function as an absolute value function. The part of this equation that is affected by the absolute value is the x plus 3. We would set x plus 3 equal to 0. We would find out that x is negative 3. And then we would know to start our table in the middle with that negative 3, and then count backwards with negative 2, negative 1, and then count forward to be, my bad, count backwards to be negative 4 and negative 5, and then count forward to be negative 2, negative 1, and then continue to fill out the table using the equation where you plug in your values of x and solve for y, or now as we know it, f of x. Okay? When we have a square root function or other even root functions, we will have something like f of x is equal to the square root of x plus 1. And what we want to do is we want to take x plus 1 to be greater than or equal to 0, find out that x needs to be greater than or equal to negative 1, and we would actually start our table with negative 1 and count up. So negative 1, 0, 1, and 2, and then plug in our values to the function and calculate our y values or our f of x values. Okay? So again, we want to be familiar with the graphs on page 232. We want to be familiar with those graphs and understand what our graph is supposed to look like. All right. If I look at f of x is equal to 1 over x plus 4, because x is in the denominator, that is called a reciprocal function. And those graphs generally look like something like this. All right. So I need to identify, obviously this is not 1 over x, it's 1 over x plus 4. The part of the equation that is affected by the function is the x plus 4. So I'm going to take x plus 4, set it equal to 0, and I'm going to find out that x would be equal to negative 4 to obtain 0. The other thing I need to know about this specific function is that I cannot actually have 0 in the denominator. Think about your domain restrictions. If I have 0 in the denominator, that makes this a no solution. And so because of that, I'm still going to create my table where I put negative 4 in the middle, but I want to give myself more than just 2 values in front of it and 2 values behind it. I'm going to go at least 3. So I'm going to go negative 5, negative 6, negative 7, and then negative 3, negative 2, and negative 1. And knowing when I plug in negative 4, that creates a 0 in the denominator. That's going to be no solution. And what that actually tells me, and we haven't really talked about this, but it's going to create a vertical asymptote. That's what it's called. And what that is a vertical line where you have, let me get the line here, and I'm going to make it a different color. All right. At x equal -4, I'm going to have a vertical line that is a line that kind of represents it's a guide for the graph. Sorry, it kind of guides the graph, and our graph will not cross over that line. And I'll show you as we draw the graph what happens. So when I plug in -5, I'm going to have, let's see, I had 1 over x plus 4 was my function. And when I plug in -5, I get 1 over -5 plus 4, which is 1 over -1, which is -1. When I plug in -6, that's going to give me 1 over -2, which is -1/2. When I plug in -7, I get -3 in the denominator, which is -1/3. When I plug in -3, I will get +1 in the denominator, and 1 over 1 is 1. And what you might realize is that I'm going to end up with these same numbers, but just the positive value. So if I plug in -2, I'm going to have -2 plus 4, which is +2, and I'm going to get +1/2. So you can see, instead of having -1/2, I have +1/2. So for the next number, I will end up, instead of a -1/3, I will have a +1/3. So if I were to plug it in, you'll see -1 plus 4 is +3, and I get 1 over 3. All right, so let's go ahead and plot these points. So this is -4, -5, -6, -7. I'm at -1/3, which is right about there. When I plug in -6, I get -1/2, which is a little bit further down, not much for though. At -5, I'm at -1. And if you can't really tell what is going on with this graph, first of all, we need to remember that the graph on page 232 looks like that. And what's happening here is my graph is shifted over, and that's why we drew this line here. This line used to be the y-axis where it would guide our graph, and the graph would just kind of run along that line. So instead of being the y-axis, now that line is at -4, x equals -4. So knowing what the graph is going to look like, I know to draw my graph so that I follow that red line, that asymptote. So I'm going to do my best here with the tablet, and it's going to kind of go like that. On the left side of the asymptote, now I'm going to graph the other lines here, or points. So -3, +1, -2, +1/2, -1, 1/3. And you can see now it's kind of doing the same behavior here. And if you're not quite sure, you could actually plug in the value 3.5, and you could plug in 3.5 and work that out, and you'll end up getting 2. And you can see that it starts to increase and go run along that line. So here I'm going to draw my graph there. Okay. Um, And what you'll also notice is that it's running along the x-axis, okay? And the x-axis actually is an asymptote for this as well, but not necessary at this point to worry about so much, other than understanding what the graph looks like, and we can start putting this all together. Okay, now looking at this next example, when I have f of x equals negative x squared plus 2, my function here is an exponential function, and the only thing affected by the exponent is x. So when I set x equal to 0, that's the middle of my table. And so 0 is going to be in the middle. And when I plug in 0, I get negative 0 squared plus 2. Well, 0 squared is 0, and there is no negative 0. So 0 plus 2 equals 2. And again, I'm going to go with two numbers in front of 0 and two numbers after 0. Um, and then plug in my numbers. So when I do negative numbers, I have to plug them in as parentheses to accommodate for the exponent to essentially convert that to a positive, because negative 1 squared is positive 1. So then the negative out in front affects that value to be negative 1 plus 2 to be positive 1. And then when I plug in negative 2, I get negative 2 squared is 4, and the negative value out front makes it negative 4 plus 2 is negative 2. When I plug in 1, I get negative 1 squared plus 2. That 1 squared is positive 1. The negative out front makes it negative 1 plus 2 is 1. And as we had talked about before, the values, the y values that surround the vertex here, where we plugged in our value to find the middle of the table, these are going to be the same. So when I plug in 2, I get 2 squared plus 2. 2 squared is positive 4. The negative out front makes it negative 4. Plus 2 is negative 2. And as you can see, I got negative 2. Okay, this works with squares and absolute value. Now, if I plug in 0, 2, I get that point. Negative 1, 1, negative 2, negative 2, 1, 1, 2, negative 2. Okay, that kind of looks like a upside down V or something. And if we looked at page 232, I would know that um, functions with the exponent of 2 look like this, called a parabola. And it could be this way or upside down. So if I graph this, I know that it's going to go down like this and create that upside down U. Okay, and that is the graph of negative x squared plus 2. When I graph f of x is equal to 2x plus 3, and I'm given this inequality here, what that's telling me is use these values of x for your table. Don't rely on any other method. So I just go ahead and create my table of values, and I have 0, 1, 2, 3, 4, and 5. And I take those, I plug them in. 2 times 0 plus 3, that's 0 plus 3 to give me 3. 2 times 1 plus 3 is 2 plus 3, which is 5. 2 times 2 plus 3 is 4 plus 3, which is 7. 2 times 3 is 6, plus 3 is 9. When I plug in 4, I get 8 plus 3, which is 11. When I plug in 5, I get 10 plus 3, which is 13. And when I plug those in, I get 0, 3, 1, 5, 2, 7, 3, 9, and I'm running out of room here, but I can kind of fake it and complete my line. And when I draw my line, I do not draw any arrows at all. And of course, I want my line to be solid, not um, dotted. Okay, so there's my line. And I want to stop at the 0 and I want to stop at the 5 to accommodate with the absolute value here. All right. The other type of problems you'll run into for the first day is when you're given this graph and you need to identify the values of different things here, like h of -8, h of -7, h of -1, h of 3, and h of 6. And then I also need to find the domain and range. Well, when I say h of -8, if you remember, functions are written as h of x or f of x equals some expression. So what this is telling you is that number that is inside the parentheses is your value of x. And what you're doing is you're evaluating. So when you plug in x, your x is -8, and whatever you get is your y. So we go over here, we go to -8, 1, 2, 3, 4, 5, 6, 7, 8. That's -8 right there. What is my y value? My y value is at 1, 2, 3, 4, 5. So h of -8 is 5. When I look at h of -7, I again am looking at the value of x, but this time at -7, and I'm looking for my value of y. So h of -7 is right here, and I look to where my graph is, and that is right there. And that is my h of -7. So my value of y is 1. So I get h of -7 is equal to 1. All right. So then I'm going to look at h of -1. So go to -1, and I go to my graph. My graph is at -1. So right there is my h of -1. So h of -1, I guess I'll write it up here, is equal to -1. And when I look at h of let's see, h of 3, I go to x is equal to 3, 1, 2, 3, and I go up to the graph. That is h of 3, and I count my value of y up 1, 2 units, so h of 3 is equal to 2. And finally, h of 6, I'm going to x equals 6, 1, 2, 3, 4, 5, 6, and my graph is right there at y equals 0. So that is h of 6, and h of 6 is equal to 0. So when they put the number in to the function notation, they are asking you what is the value of y when x is the number that is inside. Okay? Now, domain is the values of x. So what are the values of x that are um, allowed in this graph? Let's see, I need to somehow get my writing off of the graph without getting rid of my graph here. Okay, much better. All right, My domain are the values of x. So if I look at my values of x go from, they start at that -8, and they continue on all the way until we got here at 6. So my domain goes from -8 and I end at +6. So what I need to do is I need to write an inequality where x is greater than or equal to -8 and less than or equal to +6. My range is the values of y. So if I look at my values of y that are in this graph, my values of y go from about, the lowest point is, I would say, -1 and maybe 3/4, all the way up to the highest point at 1, 2, 3, 4, 5. So my highest point at 5, my lowest point here at -1.75. So my range goes from -1.75 all the way to 5, and I need to set up an inequality so that y is greater than or equal to -1.75 and less than or equal to +5. And that's what we need to know for the first day of 3.2.